Hello again. So now we're going to graph this absolute value equation. Y equals absolute value x minus 4 plus 3. Okay? For us, well, let me first begin. We're going to graph this using the roughly naive approach. But that doesn't mean that it's invalid. It just means that it's one way of doing it. These are the items that are always going to be of interest to us when we're graphing. Domain, range, in the case of absolute value, the location of the corner or vertex. I like to call it a corner, but I know that some people like to call it a vertex, okay? Basically, as you know, the absolute value is either going to look like this or like this, and that corner point is going to be the corner or vertex. We're going to find it right now, okay? And then also, we want to know the location of any X intercepts. If there are any, there may or may not be. There may be only one. And finally, we want to know the X intercept location. Okay. So having laid out what we're going to look for when we're graphing this, let's begin. So the first thing we need to know is the domain. Luckily for us, the domain for the absolute value equations is very easy. The domain is negative infinity to infinity. Now again, it goes without saying that in the event that your function represents something practical, there may be limits on the domain imposed by the physical situation. But as far as a mathematical construct in our case, negative infinity to infinity is the domain of this graph, of this equation's graph, or of this equation. Okay, the domain is negative infinity to infinity. That is to say, all the values of x, which make sense to use with this. Okay. What about the range? The range we're going to talk about in a moment, and the reason why I'm saying that is that it'll become elucidated once we have identified the location of the corner. Okay. So in order to find the corner, okay. So in order to find the corner of an absolute value functions graph or equations graph, we set the contents of the absolute value, in this case x minus 4 to 0, to find the x coordinate of the corner. So let's do that here. So if I set x minus 4, which is the contents of my absolute value, if I set that equal to 0 and I solve for x plus 4, in this case plus 4, I'm starting with a simple example because this way this process becomes elucidated and you'll be able to graph these with confidence, okay? And as we do harder examples, it'll be easier to follow having seen the simple example first. You can see here on the left, I'm left with just x by itself. X equals what? What's 0 plus 4? 4, okay? So that's the x coordinate of my corner. Now, as with any other point on a graph, how do we get the y coordinate of the point? For any x coordinate, we insert it into the equation to get the y coordinate, okay? So I'm going to calculate that here. So the y coordinate for this point will be the absolute value of 4. Notice how I'm inserting this 4 for the x, minus 4 plus 3. Aha! Notice here, what is 4 minus 4? That's 0. Absolute value of 0 is 0. 0 plus 3 is 3, okay? So we know that our corner point will be at 4, 3, okay? Okay. So now we have our corner point. Now what I want you to notice is that, what I want also for you to notice is this. Either the absolute value equation will open up or it'll open down, okay? If you look at this one, the coefficient of the absolute value, in other words, the number outside of the absolute value, in our case is positive. In fact, it's 1. That's why there's no number visible here. If it had been something like 2, we would have seen it as a number, but we remember when we don't see a number, just like when we don't see a number in front of x, that coefficient is assumed to be 1. In this case, it's a positive 1, so it opens up. So once I know the location of the corner point, once I see what that y is, and once I know that the absolute value either opens up or opens down, depending on the coefficient of the absolute value term, that allows me to get the range. In this case, we already agreed the coefficient of the absolute value term is positive. In fact, it's positive 1. So the absolute value function in our case opens up because the corner is the minimum value taken by this absolute value function. We know that the least y is 3. So we know that the range will be from 3 to infinity. Okay? Okay. By the way, I want to take this moment, it's as good as any moment, to note something important that you might want to take down in your notes as well. And that is the following fact. A lot of books will make the analogy of writing an absolute value equation like this. You'll have f of x equals a absolute value of x minus h plus k, and they'll say that the vertex or the corner in our language, okay, will be, if you have the function, it looks like this, then the corner will be h comma k, and if a is positive, then it opens up, and if a is negative, then it opens down. And I want you to know that that's also okay, but I wanted to show you this in the event that it's more complicated. Okay, yes, but so you could also look at it this way, and certainly this part about the a, the number in front of the absolute value, that is definitely true. Okay, the number in front of the absolute value tells you if it opens up or down, just like a parabola. Oh my god, I seem to be rambling here. Okay, now let's continue. Okay. So the next thing we want to know is the X intercepts. Okay. To find the X intercepts in general, we set the y equal to 0 and solve for x. Okay. So let me write that down for you. Right, so don't forget that. To find the x-intercepts, we set the y equals 0 and solve for x. So I look at this expression, this equation. We said look at this equation. I set the y equals 0. So I get, let me write this on the left-hand side just for fun. And then I'm going to set it equal to 0. Okay? And now I'm going to solve it. I'm going to solve it for x. Minus 3. Okay, because I'm trying to get the absolute value term by itself. Here I have x minus 4 in absolute value is equal to negative 3. Aha! Is there something wrong here? It's interesting. We ask ourselves the question, can an absolute value ever be negative? No. Therefore, there is no value of x which we can substitute into this expression inside the absolute value that would make this equation true, because the absolute value is always positive. Okay? And so therefore, this equation, this absolute value equation, has no solution. In terms of the practical reality of this problem, as we're trying to graph it, that means that this has no x-intercepts. Okay? Let's see if that makes sense. Our vertex is at 4, 3. So in other words, it's already above the x-axis. And as we mentioned before, since the coefficient in front of the absolute value term is positive, it opens up. So if I do a cartoon here, a very non-serious cartoon like this, if this is 4, 3, and it opens up, it's going to look like this. So this makes sense that it will have no x-intercepts. Okay? So now what we're going to do is we're going to find the y-intercept. Okay? So as before, we know that to solve the y-intercept, we set x equal to 0 and we solve for y. So let's take this expression, but we're going to set the y equals to 0. So my y is going to equal the absolute value of 0 minus 4 plus 3. Okay? what is 0 minus 4? That's negative 4. So this simplifies to the absolute value of negative 4 plus 3. What's the absolute value of negative 4? Positive 4. Okay, so this becomes 4 plus 3. And what is 4 plus 3? That's 7. Aha. So the y-intercept here, what's the x value? 0. And what's the y value? 7. Okay? And that's my y-intercept. The x-intercepts are not applicable in this case because they don't exist. And now we're prepared to make a very basic table, to which I will provide some guidance as to how best to do that. And then we're going to draw the graph together, okay? It's a beautiful thing. And let's do this, yes. Yes. Let us proceed to do this magic. Yes. No. Okay. So now, so let me also point out something else. As I mentioned before, when we were talking about the domain, I mentioned that this is the domain when we look at this absolute value equation as an equation in general, okay? And the graph that I'm about to do is more or less like the textbook graph that you would do, okay? But I wanna right up front tell you that whenever we're drawing the graph of any function, I don't want you to think that this is the be-all and end-all of what the graph of the function could be. Because let's say we were interested in how this function behaves in a certain region of x values, we would graph with those x values, okay? So in other words, what I'm about to say is I'm going to select the points that will illustrate what you would expect to see in a textbook about this kind of equation, and not necessarily the general scenario. If you wanted to investigate the function's graph near a different x value, you would make a different table with those x values, or with the x values that are in the vicinity of the x values of interest to you, and then you would plot those points, okay? But with that proviso, let's continue. In my case, when I'm drawing an absolute value, okay, I start with the location of my corner. Okay, this is my x and this is my y. That'll be my middle point. And then I'll go 2 to the left and 2 to the right, okay? So 3, 2, and then 5, 6. Okay? And then what I'll do is I'll use this equation to evaluate the y at those points. Okay? So at x equals 2, comma, the y will equal to 2 minus 4, absolute value of that, plus 3. What is 2 minus 4? That's negative 2. Okay? So this will be the absolute value of negative 2 plus 3. What is the absolute value of negative 2? Positive 2. So let me write that down. Positive 2 plus 3, or in other words, 5. So I'm going to put that in here. Okay? At x equals 3, my y will equal to, notice, I'm going to plug it in here. It'll be 3 minus 4, absolute value of 3 minus 4 plus 3. Now what is 3 minus 4? That's negative 1. So this will be the absolute value of negative 1 plus 3. What is the absolute value of negative 1? Positive 1. So that'll be 1 plus 3, or in other words, 4. I'm going to write that in here, okay? Now I'm going to calculate the y value for x equals 5. So y will equal to the absolute value of 5 minus 4, okay, plus 3. Now, what is 5 minus 4? That's positive 1. So this will be the absolute value of 1 plus 3. The absolute value of 1 is just 1. So this will become 1 plus 3, which will be 4. So I'm going to write the 4 here. And then I'm going to do the same thing for x equals 6. So if x equals 6, I'm going to get y equals the absolute value of 6 minus 4 plus 3. What is 6 minus 4? 6 minus 4 is 2. So this will be the absolute value of 2 plus 3. The absolute value of 2 is 2. So it'll be 2 plus 3, or in other words, 5. Okay? Now I want you guys to realize, you guys might have already noticed this, of course, but you can see that as I go to the left of my corner points y, and as I go to the right of my corner points y, there is a symmetry involved, right? And that's no accident. Although it's usually not discussed, just as the vertex of a parabola has an axis of symmetry running through it, the vertical line through this x value, so too does the absolute value function. So too does the graph of the absolute value function. It is symmetric about the axis, the vertical axis that goes through the corner point or the vertex, depending on whether you want to use whichever word you want to use for that. And so that's why I always pick the vertex as the middle point, or the corner point as the middle point of my table. And so now finally, we have some points that we can plot to draw this graph, okay? Okay. Now, whenever you draw a graph paper, I want you to take a look at your x values and your y values so that you can draw enough of the graph paper to show what you want, but not too much so that your graph looks like a sideshow or something. Here I have x going from 2 to 6. So I don't have to even draw any negative x values or anything. Here my y goes from 3 to 5. So I don't have to draw any negative y values. I can just literally draw the first quadrant, okay? And I can, let me see, 1, 2, 3, 4, 5, 6. And I can do like 1, 2, 3, 4, 5. So now let me plot these points. I apologize that I'm going to be in the way momentarily, but you'll see that it'll pay off. Okay? Right? I plotted this first point. This is the point 2, 5. In other words, I go 2 along the x, 5 up. This is the point 3, 4. We'll go 3 along the x, and then 4 up. So it's going to be right here. Okay? This is the point 4, 3. So it's going to go 4 along the x, and then 3 up. The next point is 5, 4. So I'm going to go 5 along the x, and then 4 up. Finally, of course, this point is the point x 6, 5, which means I'm going to go 6 along the x and 5 along the y. Okay. We can see, okay, okay, that's the graph, okay. We can see across the y-axis at y equals 7, if you notice, which is exactly what we calculated over here, okay. These are the points we used to graph it. Now let me make a little point here. As you can see, the absolute value function, it's a graph of two lines that are connected at the vertex, okay? And so if we wanted to be super technical, we only needed to plot the vertex and one point to the left and one point to the right. Because we remember from geometry that a line is determined by 2 points. So if I had the vertex and one point to the left, that piece would have been determined. And if I had the vertex and one point to the right, that piece would have been determined also. Okay? Okay. Now, let me just dress up this graph just a little bit. You don't have to do this, but I want to let you know it's possible if you wanted to. If I wanted to, I could label these points, but instead of putting the whole coordinate pair there, I could say, okay, aha, I'll give this a label, okay? And I could label the points that say A, B, let's call this one C for corner, D and E. Then if we want to, we can, the 2, 5 is labeled as A, so I could label it A. I could label this one B. I could label this one C. right? The next one I could label D, which would be here, and then this one would be E. Okay, so that way the graph still looks nice, but all the points are labeled. You don't have to do that, but I was just showing you one way you could do that. And anyway, with that behind us, let's move on to the next example, and I hope you've enjoyed this, and I look forward to seeing you again soon.